Okay, so we'll be discussing the paper 6, probability and statistics 2 for May June 2023 paper 6-3. Okay, so let's start with question number 1. There's a random variable x with this probability density function f, and then it is given like this. So the x is from 0 until 1. They want us to find out the expected value of x. So basically, to find the expected value of x, you need to know what is the correct formula or the step to find the expected value for x. Okay, so to find out this expected value of x or the mean, you basically need to integrate for the whole domain of x. Then you have to take probability, you have to take the variable x multiply with the function. Then only you start the integration. Then this is basically the formula to find out the mean. Alright, okay, so this is a general formula. So if I want to substitute everything that I have in the question here into the formula, so I need to integrate from 0 until 1. Your x is from 0 until 1. X, you just copy the x, and then you multiply with the function fx. Function fx is given here, right? So 3 over 2 and 1 minus x squared. Okay, then for me personally, I prefer to take out the constant before I do any integration. So multiply the x inside the bracket, I'm having x, then multiply minus x power 3. Okay, then only I start the integration now. Okay, integrate x, I'm having x squared over 2, where you learned all this in AS before, right? Okay, AS pure maths before. So integrate x power 3, you're having x power 4 divided by 4. And of course, you need to substitute the value 1 and 0 into the equation here, into the expression here. So substitute it, you're having 1 over 2, then minus 1 over 4. Okay, then minus, when you substitute the 0, everything is a 0. Okay, then try to simplify it. You have the answer 3 over 8 as the mean of this particular continuous random variable. Alright, so this is basically what you have for question number 1. Okay, so question number 2. We are having a club with 264 members, and then numbered from 1 until 264. Then Donash want to choose a random sample of members for a survey. Then he will use the calculator to generate the random digits. So these are the random digits that they have. So the numbers of the first two members are 106 and 121. So they want us to write down the number of the next two members in the sample. Okay, so before we can choose the member, right, you need to know when we are having 264 members, right, and if we give them every single of them a number, then the number must be in 3 digits. That means for number 1, when we want to, what is the value or what is the number that denote number 1? It should be 001. Okay, so let's say there's a person which is number 12, so the number that represents number 12 is 012. That means there are 3 digits, they goes on 3 digits every 3 digits. When you want to read the random digit from the table, right, or the random digit, right, to choose the member, you have to go through every time with 3 digits. Okay, so that everyone will have a fair chance to be selected. Okay, all right, so as an example, if you have a look for these random digits, right, so the first number that we get is 106. Therefore, you can see that the first member selected are 106, is 106. Okay, right, then after that, you read the next 3 numbers. So the next 3 number is 121. Therefore, you can see that the second member is actually with the number 121 being selected. How about the third one? So the third one, we need to go through with the 3 digit also. So let's have a look for this one, 180. Therefore, the next member with the number 180 will be selected to do a survey. Okay, then next one, after 180, the next number will be 121. Okay, so if the next number is 121, if you try to observe, right, 121 has been selected just now as a second member. So that means this member will not include it again in the group, okay, in the selected member, because it has been selected just now, right? Okay, then how about the next one? So we'll proceed further. The next 3 digit will be 4783. Okay, so for 473 also we'll ignore it. Why? Because 473 already out of the range that we have, which is 264. The maximum number that we have is 264. So 473 already more than 264. Therefore, we are not going to include this member being selected. Then continue further for the next 3 digit, it will be 227. So 227, if you double check, it has not been selected before and it is still within the number 001 until 264. Therefore, my next member will be with the number 227 will be selected. Okay, so this is how we go through the random digits or random number table to select the member or select someone. Okay, so that they are all having the fair chance to be selected. Okay, so this is what we have for part A. And let's have a look for part number B. So for part number B, they said to obtain the number for member after the fourth member, donor starts with the second random digit 0 and obtains the number 061 and also 211. So that means now he repeated to use the same set of value again, start from 0. So the next one will be 061 and then 211 and so on. Okay, so for this question they are asking, explain why this method will not produce a random sample. So we need to know when you want to select someone, right, or select something, you have to make sure that it is a random sample. It's a random number lah. Okay, it is random. All right. But if let's say you are using the same set of random digit that you used in the first round, now the second round you are still using the same set of digit, basically you can see that they are not independent, right? Because all the digits here are repeated. Okay, although you start with the second digit, all right, but all the numbers here, the digits here are limited, so you are still repeated the same set of value. Okay, although the member that you selected might not be the same, but it is not a good one because they are not independent enough, right? Because it's still related to the previous, the numbers here are still related to the first round when he used this number to select the members. Okay, all right. So what we can do here is we can try to explain. So you can use any way that you prefer. All right. So for me, I will just, for what I observed from the marking scheme, then they are saying that all these numbers, right, are actually not independent. Okay, so are not independent of previous numbers. Okay, because all the digits here are being repeated already. Okay, there are no new random digits available. Okay, so when you use back the same one, basically they are not independent anymore, right? Okay, so this is how we answer question number 2. All right, so question number 3, we are having 100 students at Luciana's college. Their ex-students say that they like exams, so she want to use the result to find an approximate 90% confidence interval. Okay, so the 90% confidence interval is for the proportion P. Okay, not for the mean, but it is for the P. For all students at her college who like exams. Her confidence interval had width of 0.15792. So by using all this information, they want us to find out the two possible values of X. Okay, right, so before you want to find out the answer, right, let us have a look for the detail of 90% confidence level first. When I'm having 90% confidence level for proportion, for P, basically the lower limit is P minus Z, then square root PQ over N. And then the upper limit will be P plus Z square root PQ over N. Okay, so if they are talking about the width here, right? So highlight the keyword width. So how can I get the width for this particular interval, confidence interval? So to take the width, you need to take the upper limit minus the lower limit. If you take upper limit minus the lower limit, therefore the general formula for the width, okay, for this confidence interval for proportion, it will be 2z and then square root PQ over N. Okay, so this is the formula for width, and now we are going to apply this formula and equate it with this value so that we can slowly solve for the value of P. Okay, right, so since they are saying that width is equals to 0.15792. Okay, so if I substitute the formula for width, it will be 2z, then square root PQ over N equals to 0.15792. Okay, so if you glance through the formula, right, P I don't know and I want to find it out lah. Q is 1 minus P, so no problem. I can substitute Q with 1 minus P and then I can get an answer for P. N I know the value. N is actually the sample size, which is 100 students, 100. Okay, so now we have another problem is the Z. We need to find the value of Z first for the 90% confidence interval. Okay, so for 90% confidence interval, how to find the Z? Basically, you should know that the 90% meant for the center part. Okay, 90% meant for the center part of a normal graph, and then the side they are having 0.05. This side also having 0.05, which means that if I want to find out the value of Z, basically it should be the whole area below the Z, which is 0.95. Okay, so I should look for 0.95 to get the correct value of Z for my confidence interval, right? Okay, so looking for 0.95, we can go to our normal distribution table. Okay, so let's scroll down to the bottom. Okay, so let's have a look for here. I'm having the probability, I have the value of Z. So my probability is 0.95, right? Therefore, what is my value of Z here? So it is 1.645. Okay, this is somehow like a shortcut of the table that we can use, right? So we are having 0.95 probability, the Z value is 1.645. So come back to the question here, we will substitute the Z equals to 1.645. Okay, and after that, again, P is a P lah, no problem. Then Q, I want to replace it by using 1 minus P, so that I'm having the P as a main variable. Okay, then divided by N, N is 100 sample size, then equals to 0.15792. Okay, so now you might need to use calculator to help you a little bit. Move all the two 1.645 square root and 100 over. Okay, so please move it slowly, all the numbers slowly. By right, you will get a number 0.2304 on the right. And then from here, I actually can observe that I get a quadratic equation. Okay, in terms of P. So this is a quadratic equation. What am I going to do is, to find the value of P, of course, you can use the help of calculator, okay? Or maybe you can use the help of formula to help you lah. So I'm using formula where I should have negative B plus minus B square minus 4, A is a 1, C is 0.2304. Okay, and then divided by 2A. Okay, so when I divide it by 2A and use calculator to help me, surprisingly, I'll get a very nice value for two nice values are for P. One of them is 0.64 if you didn't do any careless mistake. Then another value for P that I get from calculator is 0.36. Okay, and now for this question, they're asking for the X. They are not asking for the P, right? Okay, so what is the relation between the X and also the P? P is the probability. X is the number of the certain of the student. Okay, so to link X with P, right? Basically, what is the formula for probability of proportion? It is actually the value of X divided by the total size, right? Okay, so our N is 100. So to link X with P, P is actually equals to X over N. So I replace it by using X divided by 100 equals to 0.64. And after that, X equals to X divided by 100 equals to 0.36. Okay, so from here, I think it's quite obvious already. Your value of X basically is equals to 64 and also 36. Okay, so this is how we solve this question number 3. Then let's proceed to part B. Okay, so for part B, Susma independently took another random sample and found another approximate 90% confidence interval for P. Find the probability that neither the two confidence interval contain the true value of P. Okay, when we talk about confidence interval, right? 90% means what? 90% means that we are 90% sure that the confidence interval contain P. Contain true P. The true value of P lah. Okay, so if for one confidence interval, we are 90% sure that it contains the true P. That means 10% we are having the confidence interval do not contain P, right? Do not contain P. So basically that's the meaning for the confidence interval. You should know about it lah, right? Okay, if I know that for one confidence interval, it is 10%, we have a 10% chance that this interval do not contain true P. And now we are having two confidence intervals and both of them do not, none contain. So both of them do not contain the P. For first confidence interval, if it do not contain the P means 10%, it will be 0.1. For second confidence interval, it also didn't include or didn't contain the true value of P, which is also 0.1. So when you multiply these two values together, you should get 0.01. So this is for the first confidence interval. This is for the second confidence interval. So when you multiply them together, it will be equals to 0.01. Alright, okay, so this is how we answer question number 3. Alright, so we come to question number 4. Okay, so we have the mass in tons of steel produced per day at factory is normally distributed. So I think you should highlight the keyword normally distributed with the mean 65.2 and also the standard deviation 3.6. And we are going to assume that the mass of steel produced each day is independent of the other day. The factory makes $50 profit on each ton of steels produced. They want us to find the probability that the total profit. So I think you should highlight the keyword total profit made in the randomly chosen day, 7-day week is less than this one. Okay, so for this question, before we can set it up, basically we need to know, alright, so what is the variable that is normally distributed? So for normally distributed variable, we are talking about the mass. Okay, that means the weight of the steel. Okay, so usually for this one, we'll denote it by using X. Okay, so take note, X is actually the mass in tons, right? And it is normally distributed with this mean and also standard deviation. So if I want to write out, it will be X is normally distributed, and then the mean is 65.2, standard deviation is 3.6. But you have to write out a variance here, right? So you have to be 3.6 squared. Then for this variable X, please highlight the keyword also per day. This is for 1 day. Alright, and now we are interested to get the total. Okay, but they are talking about total profit. Okay, so before I can get the total profit, right, I should know what is the weight produced in the 7 days first. Okay, the total mass of the weight, the total mass of the steel produced in the 7 day. Then only I proceed to the profit side. Okay, so the keyword is total steel. Now I want to know in 7 days, what is the mean and also the variance, okay, for the mass of steel in 7 days. Take note, this is in 1 day, right? So for total profit, if you want to write it out, it should be the expected value of 7x, which means that you're having x1 plus x2 plus x3 until x7. So when you're having x1, x2, x3 until x7, right? So basically the formula will be 7, then multiply with the mean of the original x, which is 65.2, and then you get the value 456.4. Then after that, if I want to get the variance, so by right, when I write 7x here, but actually the meaning is total, the sum. That means I'm having x1 plus x2 plus x3 until x7. So for variance also, we are having variance x1 plus variance x2 plus variance x3 until variance x7. So you add them for 7 times, so you can multiply it with 7. And then 3.6 squared. Okay, so they are 90.72. So please take note that for common mistake, there's no square for the 7 here. Okay, because the keyword is total. They are not talking about 7 times. If let's say 7 times, when you want to calculate the variance, there should be a square. But when you're talking about total, that means they are only the sum. So when they are having only the sum, you're having 7 times of variance x. That means you add variance x for 7 times. Therefore, the formula should be 7 times 3.6 squared. This is the total mass produced. Okay, the mean and also the variance are for the total mass produced in 7 days. Okay, so now we come back to this question because they're asking for the probability. Okay, if I want to calculate the probability, right? Okay, they are talking about total profit. So total profit is less than 22,000. Okay, but for me, my problem is I'm having 7x, which is the total mass produced. How can I link the mass with the profit? Okay, so let's say I'm having the mass, all right. If let's say profit, so okay, maybe I put it like this. If let's say profit is smaller than 22,000, how can I get the profit? So the profit is actually 7x multiplied with 50, right? Because they are saying that the factory makes $50 profit on each ton. So that means if let's say I'm having 7x ton in 7 days, so the total profit will be 7x multiplied with 50 is smaller than 22,000. Okay, then I prefer to keep my variable as 7x. So what I do is I will try to move the 50 over. So it will become 22,000 divided by 50. So everything is in tons. It's easier for me to do the calculation for the probability. All right. So I will take 7x smaller than 22,000 divided by 50. Because per ton is 50, right? So I want to know roughly how many tons do I have here. Okay. So when I take 22,000 divided by 50, then I have smaller than 440. Okay, if x is normally distributed, then the linear random variable 7x, linear combination of the x which is 7x is also normally distributed. Okay, if I know that it is normally distributed, to calculate the probability, of course, I need to change it become z, right? So how to change it become z? You have to standardize it. So you take the value of the 7x minus the mean. What is the mean that you calculate just now for 7x? This one. So 456.4. Then divided by standard deviation. What's the standard deviation that we get? Just now we get a variance, 90.72. So standardized, I need standard deviation. So I have to take square root of 90.72. Okay, then after you standardize it, of course, you need to get the value of z, correct to 3 decimal place. I'm having negative 1.722. Okay, so how can I get the probability for x smaller than z smaller than negative 1.722? So in your mind, maybe you have to imagine the area that you want to find. This is negative 1.722. They want you to get this probability or this area. Okay, but of course, in my normal table, they didn't provide any probability for negative value of z. Therefore, I need to try to imagine the same area for the positive value of z. So for the positive value of z means that I'm having 1.722 on the right hand side. And then this is the same area that I want to find. Okay, all right, then again, if I want to find the small area here, basically for normal distribution table, they only provide us with the large area, which is smaller than 1.722. So to get this greater than 1.722, you have to take 1 minus the value that you get from the table to get the green color area. All right, so this is basically our step. So I will take 1 minus, I will look for 1.722 from the normal distribution table. Okay, let's have a look. Where is my 1.722? Okay, so this is my 1.7. 1.72 is this one, right? 1.72, and then you go for the 2 at the back. So you can see that basically I'm having 9573. I have to plus 2, where I get 9575. Okay, so I go back to my solution here. 9575, right? Okay, correct, 9575. So let's continue. I have to take 1 minus 0.9575, which is the red color area that I show here. Then when you take 1 minus, basically you can get the small green area on this side, which is the same also with this one. All right. By right, if you didn't do any careless mistake, it should be 0.0425. Okay, so basically this is what we have for question number 4. Alright, so we try to keep my variable as tons, okay, the mass of the steel. Then to link the profit, okay, with the mass, basically I take the total profit divided by the profit per tons. Alright, therefore you can get the 440. So this is how we solve the question number 4. Okay, so let's continue to question number 5. Okay, we are having last year, right? The mean time for pizza deliveries from this pizza shop was 32.4. And then this year, the time for the pizza delivery was recorded for a random sample of 50. So you should know this is 50. The result as follows. So we are talking about the mean time, the time, okay, for the pizza deliveries. Okay, so this is a sample basically because you're having a set of data with 50, right? 50 deliveries. So this is basically a sample. So for this sample, they want us to find the unbiased estimates of the population mean and also variance. So to use a sample to estimate the population mean or variance, right? There's a specific formula that you have to apply. You can refer to our formula booklet. And then I think it should be somewhere here. We are talking about sampling and testing, right? And we are interested for unbiased estimators. So basically, this is the formula for mean, the unbiased estimates for population mean. These are the formula for unbiased estimates for population variance. Okay, so please note that they are having two lah. So this is the first equation and this is the second equation. Right, so which equation to be used? It depends on the data given in your question. So for our question just now, we can actually use this one because we are provided with the summation x squared and also the summation of x. Okay, then for mean, there's only one formula. That's it. So we can straight away apply. Right. Okay, so we continue to our question. Alright, so to calculate the unbiased estimated mean or population mean, it is actually summation of x divided by n. So what's the summation of x here? Oh, sorry, for now I cannot use the x, right? Because in our question it is t. So summation of t is 1700, then divided by 50. Okay, so my unbiased estimated value for the population mean is 34. Okay, then now I continue to the unbiased estimated variance. Okay, so for unbiased estimated variance, right, the general formula is 1 divided by n minus 1, then summation of x squared minus the summation of x the whole thing square divided by n. If I substitute all I have here in our question, so 50 minus 1 is 49. Summation of x squared, oh sorry again, I have to change it back, become t. Okay, so summation of t squared will be 59050, then 1700 square divided by 50. Again, by pressing calculator, you will get the answer like 1250 divided by 49. Okay, so for me personally, I would prefer to keep the unbiased estimated variance in a fraction form. If you try to press calculator, this is a long decimal number. Okay, and I believe that in part B later, I might want to use this value. So to keep it as original as possible, usually I will keep it as a fraction form. All right. Okay, then let's have a look for part B. Okay, so when you're at question number B, they want us to carry out the test at the 2% significance level, whether the mean delivery time has changed since last year. Highlight the keyword change. This is actually the keyword to help us set up the alternative hypothesis. Okay, so again, they are talking about the mean time, right? So we actually want to find out what is the population mean, whether the population mean has changed or not since last year. Okay, so to carry out the test, for the first step, we need to set up the null and also alternative hypothesis. For null hypothesis, it should be mu. Mu means population mean. So I'm using this symbol. So please don't use the symbol mean x. Cannot. Because we are testing on the population mean. We are not testing on sample mean whatsoever. So please take note that the symbol is very important here. Okay, so we are having mu. Then what is the original mean for last year? So you go back to the question, part number 1. They are saying that, oh, the original mean time for last year was 32.4. That means all my null hypothesis will be mu equals 32.4. And now we are going to check and see whether the mean time has been changed. Okay, has changed or not. Right, so the keyword is here. Okay, sorry, let me go back. Okay, so it is in minutes. Right, so to set up the alternative hypothesis, we need to use the keyword change. So change, it can change become longer. It can be changed also become faster, right? The shorter time. It can be longer time or shorter time. So that means the change is in two direction. So when you're having the changes in two direction, and we want to test the alternative, right? It should be not equals to 32.4, where this is actually a two-tail test. Okay, so to carry out the test, first step I need to write out the null and alternative hypothesis. Okay, then for me, since this is a two-tail test, right? For me personally, I will try to draw a normal distribution graph to show where's my rejection region. This is a two-tail test, therefore my rejection region will be on both sides, both ends. Okay, and then what is the area for the both end here? Okay, the total area for both end will be our significance level. Okay, so again, our significance level is 2%. That means one end will be 1%. So this one will be 0.01. This is also 0.01. Okay, so you can see that these two sides, when I shaded it, it is actually our rejection region. Okay, so to know whether I want to reject my alternative or null hypothesis later or not, now I need to find out what is the value of Z here. So we call this particular Z as critical values. Okay, that separate the rejection and also the acceptance region. Okay, so these are also the critical value, just that one is positive value, one is negative value, because they should be symmetrical to each other, right? This is a symmetrical graph. Okay, so to find the value of Z for the critical value, I need to observe the whole area smaller than this value. Okay, so what is the total area for this one? You're having 1% at both sides. This one will be 0.98. So to look for the critical value, it is 0.98 plus 0.01. So we should look for the area 0.99. Okay, go back to our normal distribution table. Scroll down to the bottom. Okay, so just now we are talking about our area should be 0.99, right? So this is a 0.99 area, and the respective value of Z, the respective value of Z is 2.326. Okay, right, so I go back. My critical value here will be 2.326. And of course, this value will be negative 2.326. Both of them are actually my critical values. Okay, so I try to write out the critical values. Critical values will be plus minus 2.326. Okay, so after you find the critical value, you need the test statistic. Okay, so that I can use the test statistic to decide whether I want to reject or accept the null hypothesis. Okay, so I will write my test statistic here. So what is the formula for test statistic? Okay, so the formula will be Z equals to, you have to take the sample mean minus the population mean divided by standard deviation over square root n. It is a sampling formula because we are using the sample to calculate the test statistic, right? Okay, so what is the sample mean? Again, if we try to go through with the part just now, we actually get the sample mean, right, which is 1700 divided by 50, and the value should be 34. Okay, so the sample mean for this case will be 34 minus the population mean. What's the population mean? It is something that we want to test here, so minus 32.4 divided by standard deviation over square root n. Okay, so to use the standard deviation, right, it has to be the population standard deviation, and we have estimated the population standard deviation just now in part A, which is 1250 over 49, right? So I need to take the square root of 1250 over 49 so that I can get the square root variance, which is the standard deviation. then divided by the square root n. So I'm still under the square root, n is 50. Okay, all right, then just use calculator to help you. You will get your test statistic equals to 2.24. Correct to three significant figure. Okay, and now I can see that 2.24 is my test statistic. Critical value is 2.326. If I want to put in my 2.24 into my graph, so where should I place it? So 2.24 compared with 2.326 is smaller, right? So by right, 2.24 should be somewhere here before the 2.326. And you can see now this particular green color line 2.24 falls under the acceptance region because the shaded part is rejection region, right? So this one falls under the acceptance region. Okay, so before you can make any conclusion, what are you going to do is you need to do a comparison. We are comparing, right? So you can write the reason here. You observe that, oh, test statistic. Okay, so which is equals to 2.24. Okay, and you can see very clearly that it is smaller than the critical value, which is equals to 2.326. Okay, all right, so since test statistic is smaller than critical value, and from the diagram you can see that it actually falls under the acceptance region. Okay, therefore we do not accept the null hypothesis. Do not reject, not accept, do not reject, because we're talking about whether are we going to reject the null or accept the null. So this one is acceptance region, therefore you accept or you write it as do not reject the null hypothesis. Then of course we need to make a simple conclusion in the by using the context of the question. Okay, if we don't reject the null hypothesis, right, it means what? It means that there's no enough evidence, or you can write insufficient evidence, okay, to show that no evidence, but sorry, no enough evidence, no enough evidence, okay, to show that the mean has changed since last year. The mean delivery time, okay, I need more space here, okay, has changed since last year. All right, so this is how we solve it. Okay, and then in your step, please make sure that you include all the important points here, important result here. The first one, of course, is null and alternative hypothesis. The second one that you need to show is the critical value. Next one is the test statistic. After that, the comparison. Okay, how you decide whether you want to reject or accept the null hypothesis. And finally, followed by the conclusion. All right. Okay, so this is what we have for part B, question number 5. Let's proceed to part C. Okay, so they're asking under what circumstance that would it not be necessary to use central limit theorem? Do not use the central limit theorem in answering part B. Okay, usually when we didn't use any central limit theorem with only one reason, that means when your population is normally distributed, then we do not apply the central limit theorem. So you can just write it like this, when the population is normally distributed. Okay, but because we are talking about the time of the pizza delivery, right? So you can write like this, when time in population is normally distributed. So when population already normally distributed, we actually no need the central limit theorem to assume that, oh, the sample also normal. Okay, right, so this is what we have for question number 5. Okay, then now we come to question number 6. Okay, so we are having 1 in 5,000 people in Atalia have certain conditions. So there's a random sample of this amount of people from this Atalia is chosen for a medical trial. The number having the condition is denoted by X. So use a appropriate approximating distribution to find X smaller equals to 3. Okay, highlight this keyword. So this is a very obvious keyword. So you have to consider what kind of approximation distribution that we can use in this question. Alright, so just to recall back, right? In A2 syllabus, we are having two types of approximating distribution. The first one is we can have a binomial to change it become Poisson. That's the first type. And the second type is we are having the Poisson that we change it become normal. Okay, right. So from this question, right, 1 in 5,000, it is actually a proportion, right? 1 out of 5,000, it is a proportion. And then we're having a random sample of this total number. This is actually the total trial, okay, which is the n. So you're having p and n, right? Basically, it is binomial. And you are going to change it become Poisson distribution. Okay, so for my solution here, when I set up, I'm having x is binomial distributed with the n is 12500, the p is 1 over 5,000. And I'm going to change it become Poisson. So to change it become Poisson, right, the parameter in Poisson is lambda. So lambda is actually the mean. How to get the mean from binomial distribution? It will be n times p. So if you want, you can write it out straight away, n times p. And eventually, the lambda for the Poisson distribution is equals to 2.5. Okay, so after you change it already, then now you can start the calculation for probability. X smaller equals to 3. That means you start from x equals to 0, x equals to 1, x equals to 2, x equals to 3. Okay, so there's a formula here, E negative lambda. Lambda, that means it's the mean, right? So when x equals to 1, the value inside here is always a 1. X equals to 0, it is always a 1. When I'm having x equals to 1, the value here is always the lambda, 2.5. X equals to 2, it will be 2.5 squared divided by 2 factorial. And then for our solution here, right, they are asking for x smaller equals to 3. That means x equals to 3 should be included as well. So I'm having 2.5 power 3 divided by 3 factorial. Okay, so this is the formula for using the Poisson formula to find out the probability. Okay, then again, by using calculator to help you, you should get a Long's value. Okay, so kindly correct it to 3 significant figure where I will have 0.758. Alright, so this is how we solve part A for question number 6. Then let's proceed to part B. Okay, so for part B, they want you to find the value of EX, expected value for X, and also the variance of X. Explain how your answer suggested that the approximating distribution used in part A is likely to be appropriate. Okay, so we maybe straight away find out the mean and also the variance first. So the mean, right, is actually the lambda that we get just now, which is 12500 multiplied with 1 divided by 5,000, and you get 2.5. Then how about for variance? Okay, so the variance, right, formula is NPQ, where this is the N, this is the P, and this is the Q. Okay, so when you multiply them together, right, your NPQ is actually 2.4995 to be very accurate. Okay, so it should be 2.4995. So this is the mean and this is the variance. And then they are asking you, why I can change binomial become Poisson in this case. What actually makes it possible that we can change binomial become Poisson? Okay, so you can see that for Poisson, right, what is the special characteristic for Poisson? So for Poisson, basically, mean and also lambda, mean and also variance should be having the same value. Okay, so for this question, you can try to compare the mean and also the variance. You can see that they are very, very close to each other, which is almost the same. Therefore, we can actually change binomial become Poisson for this kind of question, for this particular question. Okay, so what's the reason? So you can tell them the reason is the mean and also the variance, okay, are almost equal. That's why it is valid that we try to change binomial become Poisson distribution to calculate the probability. Okay, so this is how we answer question number. Okay, so we are now at question number 7. we are given a random variable x that has the probability density function f. Okay, and then the graph is shown as a semicircle with center 0, 0. So you can see that this is a semicircle in the diagram. And then the center is this point 0, 0, and the radius is square root 2 over pi. Entirely above the x-axis, where elsewhere the fx equals to 0. So the diagram represents very nicely the whole curve, okay, for the function fx. Verify that f can be a probability density function. Okay, so to prove that the fx is a probability density function, right? There are two important property that we need to show actually. The first one is we have to show that fx greater than 0, which is always positive. And this is true because you can see that the whole curve is above the x-axis. So that means the first one is already being proved, okay? Then for the second property that we need to prove is the area under the graph for the function, right, should be equals to 1. That means the total area or total probability should be equals to 1. It cannot be more than 1. Okay, so to prove, right, so first of all, you can make a simple conclusion on the first property first, where fx greater than 0. So that means on the whole fx, okay, lies above the x-axis. This also concludes that our function fx is greater than 0, okay, for the domain that it is defined. So this is the first property. And the second property is we are going to prove area under the graph should be equals to 1. Okay, so for the number 2 one, I'm interested to find out the area under the graph. Okay, so how to calculate the area under the graph? Basically, it is the semicircle, right? So what's the formula for the semicircle? So for circle, it is pi r squared. So semicircle will be half pi r squared. We need to substitute the r into our calculation. So what's the r? It is given that the radius is square root 2 over pi. So I'm using square root 2 over pi. And then I square it. Okay, then I have 2 over pi here. Then when you simplify, it is equals to 1. Okay, so we are proving the two properties for probability density function already, so we can make a simple conclusion where f is a probability density function. Okay, so this is what we have for part A. And then now let's proceed to part number B. Okay, for part number B, they are saying that A and B are the point where the line x equals to square root 1 over pi meets the x-axis and the semicircle respectively. So you can have a look here. What is the point A and point B? So you can see from here, point A and point B are having the same x coordinate, which is square root 1 over pi. Okay, it is x equals to square root 1 over pi. And then they want us to show that the angle AOB is pi over 4 radian. And after that, find out the x which is greater than square root 1 over pi. So we need to prove the first thing first. The angle AOB is pi over 4. Okay, so to find the angle AOB, which is equals to pi over 4, we can have a look for the diagram first. We can use diagram to help us basically. Okay, if I have a look for the diagram here, right, I'm interested to find out the angle AOB, this one. Okay, so before that, maybe I can use some useful information here first. I can try to find out OBA first. Okay, I can try to find out OBA first. How to find the OBA, angle OBA. So maybe what I can do is I can use this length, the length OB. Okay, so what's the length OB here? Okay, the length OB here basically is the radius, right? So radius is square root 2 over pi. I can also use this OA, the length OA. What's the length for OA? It is square root 1 over pi. Okay, so square root 2 over pi is the hypotenuse, which is the radius. 1 over pi square root is actually the length for OA. Okay, so from here, maybe I write the proving part here so they can see the diagram clearly. Okay, so now I'm having, I try to use the function sine. If I have sine angle OBA. Okay, so you see sine angle OBA means this one, right? So for this particular angle, the sine is opposite over a hypotenuse. So it should be equals to OA divided by OB. Okay, all right. Then now I want to substitute in the OA. What is the OA? So like what I showed you just now, it is square root 1 over pi. What is OB? So OB is square root 2 over pi. Okay, so when you try to simplify the term here, right, basically you're having 1 over square root 2. Okay, so to get the angle OBA, it is sine inverse 1 over square root 2, and therefore you get pi over 4, which is 45 degrees. Okay, then finally I want to find out the angle AOB. So to find the angle AOB, right, you should know that the total angle for the inside a triangle, this one, and also this one, okay, the total angle inside the triangle should be 180 degrees or pi. So if I want to find out the angle AOB, right, I can take pi, 180 degrees, minus the right angle, 90 degrees, minus the angle OBA that we found just now, pi over 4. So from here, you actually get the angle, which is pi over 4. So this is what they want us to show, right? Okay. Yeah, so this is what you have for part B, the first section. Right, so to prove the angle AOB is equals to pi over 4. Then now we want to proceed to the second part. After we show the angle AOB, we want to find out the probability of x greater than square root 1 over pi. Okay, so again, to find out the answer for the probability for x greater than square root 1 over pi. Okay, there are many ways that you can solve it. Alright, you can maybe integrate the function, but too bad we in this question we don't have the PDF, the function formula. Okay, it is not provided in our question, so you cannot integrate it straight away. So maybe we can use some knowledge in area, okay, to find out the probability. They are interested for x greater than square root 1 over pi. Okay, where's the probability or area for x greater than square root 1 over pi? So this is basically the probability. The area under the graph that is more than square root 1 over pi is the probability that we want to find. So this red color shaded area is the area that I want to find. Okay, so to find out this particular area, what can I do is we can use the area of the quarter circle, 1 over 4 of the area of the circle, right? And then we can minus the area of the sector. That means I minus this one, minus the green color one, then minus the triangle OAB, then I will get the red color area here. Okay, so to minus the area of the sector, right? Just now we already know that this is 45 degrees. So automatically we should know that this is also 45 degrees or pi over 4. Okay, then the radius we already know, right? Radius is square root 2 over pi. All right, so basically it's like this, and we take the 1 over 4 of circle, the area of circle, okay, minus the area of sector, which is this one, okay, minus this one, then minus the right angle triangle, okay, then I'll get the area, okay, for the value x greater than square root 1 over pi. Okay, so this is basically our step, right? Okay, so I'll write it at the bottom here. Okay, so I'll write out again. I want to have 1 over 4 of the area of circle minus the area of sector, then minus the area of the triangle OAB. Then I will get the answer for the probability that they want us to find. Okay, so what's the area of circle? 1 over 4, I just copied. Area of circle will be pi r square, right? So pi r is square root 2 over pi, and then square. So I'm having 1 over 4 pi r square minus the area of sector. So as the area of sector, half r square theta. So half r square is still the same, square root 2 over pi. This is r square, and then theta. So just now I show you, right, the angle should be pi over 4. Then minus the area of triangle OAB. So to minus the area of triangle OAB, I will use the formula half AB sine C lah. So I'm using half. I know this length, I know this length, I know this angle. So half AB sine C. Okay, so I'm using half. Then the hypotenuse length is square root 2 over pi. Then the horizontal length, OA, is square root 1 over pi. So half AB sine C. So sine, the angle is pi over 4. Okay, so what you need to do now is try to simplify all the terms here slowly to avoid any careless mistake. Then eventually you can get the answer. Okay, so r squared, I'm having 2 over pi here. Then for this one, I'm having 2 over pi also. And then pi over 4. Okay, so next term I'm having 1 over 2. Then I'm having square root 2 over pi. Here, right? Square root pi, you get a pi. Square root 2 times square root 1, you get still a square root 2. Then sine pi over 4. What is the value for sine pi over 4? It should be 1 over square root 2. Okay, after that, we simplify slowly. For first term here, pi and pi can be cancelled off. So you left only half. Right? Okay, then for the second term, pi and pi can be cancelled off. 2 and 2 can be cancelled off. We are having 1 over 4. Okay, and after that, for the last term here, anything else I can cancel off here. This one, square root 2 and square root 2 can be cancelled off. So I'm having negative 1 over 2 pi. Alright, then simplify your answer. You should have 1 over 4 minus 1 over 2 pi. Or if you want, you can change it become decimal number where it should be 0.0908 correct to 3 significant figure. Right, so this is what we should have for this particular question. Okay, so to find out the probability, we're not able to integrate because we don't have the function of fx. Therefore, you have to use some common sense on area, where area actually denotes the probability. All right, to try to find out the probability. Okay, so this is how we answer question number 7. Okay, so now we are at the very last question for this paper. There's a new light was installed on a certain footpath, and then we are going to decide to use a test to investigate whether the number of people using the path in the evening has increased. So please highlight the keyword increase. This is the keyword to help us to set up the alternative hypothesis then, right? Okay, so before the light was installed, the mean number of people using the path during the 20-minute period is 1.01 for 20-minute period. Okay, so you can see that this is the time interval, okay, and then this is the mean. So basically, it is having a Poisson distribution style, right, or Poisson distribution structure. Okay, so after the light was installed, the total number n using the path during 3 randomly chosen 20 minutes. So that means it is still total they are 60 minutes, but they separate into 3 different 20-minute period during the evening was noted. So they are using this as the test, all right, the data from these 3 periods as a value for the test to carry out the test. Okay, so now given that the value of n was 6, use a Poisson, so highlight the keyword Poisson distribution to carry out the test at the 5% significance level. Right, so we want to carry out the test by using Poisson distribution. We are actually testing the lambda or the mean. Okay, so first step, we have to set up the null and alternative hypothesis definitely. So what is the null hypothesis here? Okay, so the null hypothesis is lambda. Okay, our original mean for lambda for the 20-minute period is 1.01, right? So our null hypothesis should be 1.01. Okay, but when we are carrying out the test, we are using 3. Therefore, some of us might want to change it to the lambda for the 3 randomly chosen 20 minute. One 20-minute period is 1.01. Therefore, 3 randomly chosen 20 minute will be 3.03. So you can write lambda equals to 3.03 for 3 20-minute period. Okay, of course, some of us might want to use lambda equals to 1.01 for a 20-minute period also can. All right, okay, so this is my null hypothesis. Then for the alternative hypothesis, because of this word keyword increase, I hope that you can see it, increase. Therefore, we are going to use greater than, increase means more than, right? More than the original mean. Therefore, it will be more than 3.03 for the 20-minute period. Okay, so this is the first step, all right, where you set out the null and also the alternative hypothesis. Okay, after that, for the second step, we need to calculate the p-value. Okay, for Poisson and binomial distribution, to carry out the test, we need to use the p-value approach, which is the probability. So we need to calculate for the p-value. So how can we get the p-value? Right, so again, they said if the n, given that the value n was 6, we want to use the 6 here to carry out the test. Okay, so this is actually the observed value for the 20-minute period. Okay, so when x equals to n equals to 6, right, they want us to carry out the test whether the lambda has increased or not. So I want to calculate the probability for, okay, is x greater equals to 6. Okay, so what is it greater equals to? Basically, it depends on the direction of your alternative hypothesis. So for my alternative hypothesis here, they are greater. Therefore, when you want to carry out the test, to calculate the probability, it should be greater or equals to. Because 6 is included in the data, right? So you should have an equal sign. Therefore, I want to calculate the probability for x greater or equals to 6. For Poisson distribution, you are not able to calculate this greater than direction, because if you start with x equals to 6, x equals to 7 until x equals to infinity, very hard for us to carry out the value, okay, to calculate the value. Therefore, I have to take 1 minus x smaller than 6. Okay, so what is the probability for 1 minus x smaller than 6? Okay, so first we are having e, negative lambda. When x equals to 0, it is always a 1. When x equals to 1, it is always 3.03. When x equals to 2, it is also always 3.03 squared divided by 2 factorial. X equals to 3. Okay, then x equals to 4. X equals to 5. Okay, should I include x equals to 6 or not in my calculation? So from here, you can see that there is no equal sign included. Therefore, it should stop at x equals to 5. Okay, then by using the calculator, right, let's try to press the answer for this calculation. By right, you should get 0.0870. So this is the p-value that I have. Okay, then after you get a p-value, you want to compare it with the significance level and see whether you want to accept or reject the null hypothesis. Okay, so we are comparing the p-value. P-value is actually my 0.0870. Okay, if you compare it with significance level for this test is 5%, right? This one, 5%. Okay, so you can see that it is 5%. Therefore, this value is more than significance level. Significance level, which is equals to 0.05. Okay, so after you compare them, should you accept or reject the null hypothesis? Okay, if let's say you're not really able to remember the result, right? So what can you do is that you try to imagine, let's say okay, imagine but the graph doesn't look like this, okay? You imagine there's a graph, okay? The significance level is 0.05 on the right hand side. So this one is 0.05, which is the area. So if any area smaller than this 0.05, it falls under the rejection region. So this is how I usually imagine. This is the rejection region. Okay, but now if I try to compare my p-value 0.0870, right? This is also the area, and this area definitely bigger than 0.05. Okay, it is more than 0.05, and you can see that this particular value here, okay, this line, which is a 6 actually, x equals to 6, lies under the acceptance region. So since it lies under the acceptance region, right, then your conclusion should be do not reject the null hypothesis. So do not reject the null hypothesis. Okay, so this is something that you can set up for yourself, okay, to make a, how to say, maybe it's easier for you to remember, okay, when should you accept, when should you reject, okay? So you just imagine that there's a rejection area on the right. So you compare the p-value, which is also the area, with your significance level and see whether should you reject or accept the null hypothesis, okay? All right. Then we already make a simple decision, which is do not reject the null hypothesis. And this is not enough. We have to show or make a conclusion first. All right. So what is the conclusion here? So there's insufficient evidence, okay, to show that the number of people using the path has increased. Okay, so to show that the number of people using the path in the evening had increased. Okay, so this is basically the whole process for us to carry out the test in Poisson distribution. Okay, right, then now let's continue to part number B. Okay, so for part number B, now we are having a similar test. 5% significance level was carried out using another 3 randomly chosen 20-minute periods during the evening. Okay, they want us to find out the type 1 error. Alright, so to find out the type 1 error, we need to understand the definition for type 1 error first. So for type 1 error is reject the null hypothesis when the null hypothesis is true. Okay, alright, so this is the type 1 error. And then before you can find the type 1 error, right, we need to know where's your rejection region first actually. Okay, so like just now, when I draw a simple diagram, right, of course this is not the correct diagram, but it's just for imagination to help me. I know that my rejection region is this one, which is 0.05. And then I know also, just now when I calculate my probability for x greater equals to 6, in the previous part, right, this one is x greater equals to 6. So the x greater equals to 6 still falls under the acceptance region. So now I actually want to get the rejection region, because reject null hypothesis, that means I need to know the rejection region first. So I'm interested to know for x equals to 7, right? Is it x equals to 7 falls under the acceptance region, or x equals to 7 falls under the rejection region? So I want to check and see. X equals to 7, is it below? Is it in the acceptance region, or is it in the rejection? So to carry out the calculation, what I need to do is like I calculate the probability of x greater equals to 7 first. Okay, so again, x greater equals to 7 means that you take 1 minus the probability of x smaller than 7. Okay, so again, you can continue from the step that you did in part A, right? For x equals to x smaller than 6. But for me, I just rewrite everything again. So I'm having x equals to 0, x equals to 1, x equals to 2. Okay, then x equals to 3 until x equals to 6. Okay, then if I try to find out the probability by pressing calculator, this should give you the answer 0.0350. And if you try to compare it with my rejection region, it is actually the area here is smaller than significant level 0.05. That means what? That means if I come back to our diagram here, right, x equals to 7 doesn't fall in the acceptance region, but actually it falls under the rejection region, because the area for x greater equals to 7 is already smaller than the 0.05. So that means on this area, x greater equals to 7, right, is 0.03, and therefore you can see x equals to 7 falls under rejection region. Okay, so x equals to 7 is the first number that falls under the rejection region, because previously when I'm having x equals to 6, it is acceptance. Then x equals to 7 is rejection. Therefore, x equals to 7 is actually our rejection area. And just now, you already calculated the probability for this rejection area, right? Therefore, your type 1 error is actually equals to the value that we calculate here. Therefore, you can write it in a simple way like this. So the type 1 error is actually equals to 0.0350. All right. Okay, so this is how we calculate and get the type 1 error for this particular question. So our idea is first you need to find the rejection region first. And since x equals to 7 is our rejection region, okay, then the probability for type 1 error will be equals to x greater equals to 7. Therefore, this is my answer for type 1 error. All right, so this is how we do part B for question number 8. Let us proceed to part C. Okay, so for part C, they want us to state now what is meant by the type 1 error in this context. Okay, so type 1 error, like what I told you just now, it is actually we reject the null hypothesis given that the null hypothesis is true. Okay, so we reject the null hypothesis means that we conclude or we make a conclusion that what? That the number of people using pathway has increased, right? So we conclude that the number of people using the path has increased, although it is not. So when we make the conclusion, we conclude that the number of people using the path has increased. This one means we reject the null hypothesis, right? Although the null hypothesis is true, means that although the number of people using is not increasing. Okay, right, so this is what you have for part C. And after that, for part D, they are asking, what is the further information is needed to find the probability of a type 2 error? So they actually do not want us to carry out the test. Okay, or carry out the calculation. For type 2 error, the definition is we accept the null hypothesis when the null hypothesis is false. If you want to calculate type 1 error, right? Because the null hypothesis is false, we need to have a new value of mu or the new value of lambda to continue with the calculation for type 2 error. Okay, so the first information needed is a new value of true mean, a new value of true mean. Okay, then secondly, when we want to carry out the test, right, we need to have the expected value as well. Okay, so that we can start to calculate the how to say, the type 2 error. Or maybe we actually need to know where is your acceptance region. Okay, therefore to get the acceptance region, right, we need some hint or information where we need the number of people using the path, okay, for 20 minutes in the evening. So that the calculation for type 2 error will be easier if we have this value. Alright, so basically these are the two extra information needed if we want to carry out the calculate the probability for type 2 error. Okay, alright, so this is the end of the paper here, okay, for this paper 6.3. Thank you very much for watching this video.